Hello everyone, my name is Sachin and in this video I'll discuss the question paper for part test 4. So question 51, tan of x plus y equals 33 and x equals tan inverse 3. So it's a very basic question here, x is tan inverse 3. So tan x is 3 and tan of x plus y is 33, which means tan x plus tan y by 1 minus tan x tan y equals 33. So you need to substitute tan x equals 3 in this and solve for tan y, right? Question 52, A intersection B complement whole complement, right? So what is A intersection B complement whole complement? This can be written as A complement union of B complement whole complement, right? When you take a complement, intersection becomes union. So this will become A complement union B. Now, A intersection B complement whole complement. So this can be written as A intersection of A complement union B. So what I've done is I've simplified this part first and then substituted here, right? So this you can expand using the distributive property. You will get A intersection A complement union A intersection B, right? Now, what is A intersection A complement? It is the empty set union A intersection B. And what happens when you take union of empty set with any set? You get that set again, right? So the correct answer is A intersection B. Question 53, trigonometric expressions given. So whenever you have a summation of trigonometric ratios, always pay close attention to the angles, right? So here I have 10 pi by 30 and 3 pi by 30. What happens when I add them? The sum will be pi. Similarly, if I add 8 pi by 13 and 5 pi by 13, I will get pi, right? So we have to think about cos A plus cos of pi minus A. So this will be cos A plus cos of pi minus A is minus cos A is 0, which means cos of 10 pi by 13 plus cos of 3 pi by 13 is 0. Similarly, I can say cos of 8 pi by 13 plus cos 5 pi by 13 is also 0, which means the sum of all the four terms is again 0. Question 54, sine theta plus cosecant theta is 2. Then what is sine square theta plus cosecant square theta? So in this particular question, you can just square on both sides. If you square on both sides, you get sine square theta plus cosecant square theta plus 2 times sine theta into cosecant theta is 1. So this is 4, which means you will get sine square theta plus cosecant square theta equals 2. So in general for this question, but let's look at the condition given one closely. Alternatively, I can write sine theta plus 1 by sine theta equals 2. Right? Now I can take, let us say sine theta is t, then this is of the form t plus 1 by t equals 2. If you solve this, you'll get t equals 1. Right? Also remember, related to this, not exactly to this question, but whenever you have a function of the form x plus 1 by x, right? Let us say our function f of x equals x plus 1 by x, then for all x not equal to 0, x plus 1 by x belongs to minus infinity to minus 2, union 2 to infinity, right? So this value 2 is actually one of the border values of the function x plus 1 by x. Question 55. Sine 6 degrees into sine 42 degrees into sine 66 degrees into sine 78 degrees. So just like we discussed in the previous question, always try to think about the sum of the angles or how the angles are related to each other, right? So what I observe here is that I have 6 degrees and 66 degrees. Now 66 degrees can be written as 60 plus 6, right? Similarly, if I take 42 degrees, 42 degrees and 78 degrees, I can write 42 degrees as 60 minus 18 and 78 degrees as 60 plus 18. So the given expression is sine of 6 degrees into sine of 60 minus 18 into sine of 60 plus 6 into sine of 60 plus 18 degrees. Now there is a very important result in trigonometry that is useful in various competitive exams, which is if you have a product of the form sine A into sine pi by 3 plus A into sine pi by 3 minus 3, right? So any product of the form sine theta into sine 60 plus theta into sine 60 minus theta will be 1/4 of sine 3 theta, right? So let's apply the same thing here. So if I take A equals 6 degrees, then I will get sine 6 degrees into sine 66 degrees into sine 54 degrees equals 1/4 of sine 18 degrees, right? Now, similarly, if I take A equals 18 degrees, I will get sine 18 degrees into sine 42 degrees into sine 78 degrees equals 1/4 of sine 54 degrees. Now, what do you observe here? In the question given, we have the terms sine 6 degrees, sine 66 degrees, sine 42 degrees, sine 78 degrees. So from these two expressions, I can say, I can write sine 66 degrees into sine 66 degrees as 1/4 of sine 18 degrees by sine 54 degrees, right? And sine 42 into sine 78, I can write 1/4 of sine 54 degrees by sine 18 degrees. So the answer finally will be 1/16, right? So you have a similar result in the tangent function also, and a slightly similar result in cosine function also, right? Question 56. Domain of definition of the function. So this function has two parts. The first part is 3/4 minus x square. So what is the condition for f of x to be defined? First, the denominator in the first term should not be equal to 0. And the second condition is that for the logarithm to be defined, x cube minus x should be strictly greater than 0, right? So 4 minus x per not equal to 0. This means x can be any real number except 2 or minus 2. Now to solve for x cube minus x greater than 0, we have to make use of the Wavy curve method, right? I think we discussed it in one of the earlier papers. So x into x minus 1 into x plus 1 greater than 0. Now, if you plot the roots of this polynomial on the number line, you get -1, 0, and 1. And then you can assign the sign convention plus, minus, plus, minus. So based on this, I have x belongs to -1 to 0, union 1 to infinity. Now we've written down two different conditions in this problem. X belongs to -2, x belongs to all real numbers except -2 and 2. Let us call this set A. And x belongs to -1 to 0, union 1 to infinity. Let us call this set B, right? Now the word connecting them is and. The logical connector here is and. So when do we say that x belongs to A and x belongs to B? That is, if x belongs to a intersection E. So what is the intersection of these two intervals? You get x belongs to -1 to 0, union 1 to 2, union 2 to E. So that is the domain of this function. You have a similar question in question 57. Domain of the function 1 by logarithm of 1 minus x to the base 10 plus root over x plus 2. So again, this function has two parts. You have to first find out where each individual part is different, right? Now, f of x is 1 by logarithm of 1 minus x to the base 10. This can be written as logarithm of 10 to the base 1 minus x, right? 1 by log a to the base b can be written as log b to the base a. So, okay, so I'm only talking about the first part of the function. Right, now let's say, what is the condition for log 10 to the base 1 minus x to be defined? This will only happen if 1 minus x is strictly greater than 0 and 1 minus x is not equal to 1. Right? So for the logarithm to be defined, the base should be positive and the base should not be equal to 1. Now, along with these two conditions, I also have x plus 2 greater than or equal to 0. What is the reason for this? Because you have square root of x plus 2. So x plus 2 must be non-negative. So if I solve the first condition, I get x less than 1. The second condition is x is not equal to 0. And the third condition is x greater than or equal to -2. So we have three different conditions here for the function to be defined. To solve for the domain, to find the domain, you have to take the intersection of all three conditions. So one method I generally use to find the intersection is plot each set on the number line at a different level. So here the first condition is x less than 1. This I will represent by means of a line. So this line represents all real numbers that are less than 1. The second condition is x not equal to 0. That is, if I take 0 somewhere here, then the second condition is that x can be any real number except 0. Right? The third condition is x is greater than or equal to -2. So if I take -2 here on the number line, then I will represent x greater than or equal to -2 by means of this line. And I'll put a vertical bar here. The reason being, if there is 0 somewhere, if there's a circle somewhere, it means that number is not included. And there's a vertical bar, then that number is included. Right? Now to take the intersection, remember you're taking the intersection of three different conditions. So where do you see three lines here? You see them in this region. That will help you find the intersection easily. So based on this diagram, intersection of the three conditions is x belongs to closed interval -2 to 0, union 0 to 1. So that is option B. Question 58. F is a function from the set of real numbers to the set of real numbers. The least value of a for which f of x is injective. Now, when you have a differentiable function, what is the condition for f of x to be injective? The necessary condition for a differentiable function to be injective is f dash of x does not change sign. There should be no change in the sign of f dash x. Right? So the first derivative here, f dash x, is x square plus x plus a. Now this is a quadratic expression. Remember, it must either be completely positive or it can be completely negative. It cannot be both in the set of real numbers. So that brings us to one very important result in quadratic expressions. We can say ax square plus bx plus c greater than or equal to 0 for all x belongs to R. if and only if a greater than 0 and delta less than or equal to 0. Similarly, we can say ax squared plus bx plus c less than or equal to 0 for all x belongs to R, if and only if a less than 0 and delta less than or equal to 0. So when I say the first derivative does not change its sign, it means it's either non-negative or non-positive. Now, if you look at this derivative, the coefficient of x square is 1, right? The coefficient of x square is 1, which means the coefficient of x square is definitely positive. So which case is applicable here? The case that is applicable here is this, right? So if the derivative cannot change its sign, then it must be always non-negative. So f dash of x greater than or equal to 0 for all x belongs to R. This means the coefficient of x square is already positive. So you have to make delta less than or equal to 0. That means 1 minus 4a less than or equal to 0, which means a is greater than or equal to 1 by 4. Right? So the smallest possible value of a is 1 by 4. Question 59. If the domain of the function is all real numbers, then which of the following best describes all possible values of c? So you have a quadratic expression in the denominator. When is f of x not defined? You would have a chance where f of x is not defined if the denominator becomes 0, right? But if the domain is all real numbers, then f of x is always defined. Right? For that to happen, x square plus 2x plus c is never equal to 0. Right? That means the equation x square plus 2x plus c equal to 0 has no real roots. So what is the condition for that? Delta should be negative, which means you have 4 minus 4c less than 0, which means c is greater than 1. Right? So please remember that here we use the condition delta less than 0 because the value of the expression should never become equal to 0. Whereas in the previous case, we use the condition delta less than or equal to 0 because the value of the expression may become 0, but it should not change its sign. Question 60. F of x is 2 power x plus 2 power minus x by 2. Then f of x plus y into f of x minus y. Okay, I can write f of x plus y as 2 power x plus y plus 2 power minus x minus y divided by 2. And f of x minus y is 2 power x minus y plus 2 power minus x plus y divided by 2. Now, if you were to find the product of this, the product of this, okay, so let's multiply these two. You get 2 power x plus y plus 2 power minus x minus y divided by 2 into 2 power x minus y plus 2 power minus x plus y divided by 2. So if you multiply these, the denominator is 4. In the numerator, you will get 2 power 2x plus 2 power 2y plus 2 power minus 2y plus 2 power minus 2x whole divided by 4. right? So this can be written as 2 power x whole square plus 2 power y whole square plus 2 power minus x whole square plus 2 power minus y whole square whole divided by 4. All right, now what I can do here, I need to write these in terms of f again. So 2 power x whole square plus 2 power x, 2 power minus x whole square. I can write as, oh wait, I think we already have an answer here. We don't have to go this further because, so always keep an eye on the options because you have to simplify the given expression into one of the four, right? So what I can do here is I can take 1 by 2 common first. And the remaining expression I can write as 2 power 2x plus 2 power minus 2x by 2 plus 2 power 2y plus 2 power minus 2y by 2. But this is nothing but half of f of 2x plus f of 2y, right? F of x is 2 power x plus 2 power minus 2x by 2. So if I spot x being replaced by 2x, it means I have f of 2x, right? So that is one of the options. So that is the correct answer. Okay, question 61. Domain of f of x equals step x minus 1. So again, I'm writing the conditions here. The first square root contains step x minus 1. So step of x minus 1 should be greater than or equal to 0. And at the same time, 4 minus step x should be greater than or equal to 0. Now from here, I have step of x greater than or equal to 1 and step of x less than or equal to 4. What does this mean? It means that step of x can either be 1, 2, 3, or 4. Right? Step x should be greater than or equal to 1, less than or equal to 4. So what is the solution to this? I can say x belongs to closed interval 1, open interval 2, union, closed interval 2, open interval 3, union, closed interval 3, open interval 4, union, closed interval 4, open interval 5. Right? For step of x equals 1, you have the first interval. For step of x equals 2, you have the second interval. And finally, what is the union of all these intervals? It is closed interval 1, open interval 5. So that is the correct answer. Question 62. F of x is a cubic function here, x cubed plus 6x squared plus 9x plus 7. You have to find out whether f of x is 1, 1 or 2. So again, similar to one of the previous questions here, you have a differentiable function. So you can use the first derivative test. So what is the first derivative here? F dash x will be 3x squared plus 12x plus 9. Right? So this can be written as 3 times x squared plus 4x plus 3. So remember in that earlier question, we discussed that the first derivative should not change its sign. Now I have f dash x is greater than 0 if x belongs to minus infinity to minus 3 union minus 1 to infinity, and f dash of x less than 0 if x belongs to minus 3 to minus 3. So what do you observe here? What you observe is the derivative changes its sign. It is positive for some values of x and negative for some values of x. So from here you can conclude that f is not 1, 1. From this conclusion you can say f is not 1. Now let us look at whether f is onto or not. For that we have to compare the codomain and the range, right? So what is a codomain in this question? For this function, the codomain is given as all real numbers. Now we have to find out the range of this function. So f of x is a cubic function. right? For a cubic polynomial, the range is always all real numbers. The reason is you have f of x equals f dash x equals 0 if x equals -3 or -1, right? So at these points, the function either has a local minimum or a local maximum. What is the limit of the function as x tends to infinity? As x tends to infinity, f of x also tends to plus infinity. And as x tends to minus infinity, f of x also tends to minus infinity. So if you were to look at the graph of this function, if I had to plot the graph of this function, I could say that f of x starts from minus infinity, then it has one local maximum, one local minimum, and then it increases again, right? So you would get a local maximum at -3 and local minimum at -1. So when x is greater than -1, f of x is increasing. So it will tend to plus infinity. And when x is less than -3, f of x is also increasing again. So what is the range of the function? Conclusion here is the range is the set of all real numbers. And because the range is the same as the codomain, we can conclude that f is onto, right? So the correct answer is f is onto, but not 1. Question 63, 25 people employed for program 8, 50 employed for B, 20, 10 for both. So there's a question from set theory. So let us say number of people employed in program A is n of k, this is 25, n of B is 50, and number of people employed in both. How do we represent that in set theory? We have A intersection B, this is 10. Now number of employees, number of people employed only in A. So this is nothing but n of A minus B, right? A minus B represents the set of all people who are employed only in A, but not in B, right? So we need to find A minus B. So you can use the Venn diagram for this, or you can also use the properties of union and intersection. So generally we have A minus B. A minus B can be written as A minus A intersection B, right? And since A intersection B is a subset of A, because A intersection B is a subset of A, you can say n of A minus A intersection B is n of A minus n of A intersection B. So this is 25 minus 10, that is 50, right? Same thing you can do using a Venn diagram. In fact, I think some of you would find that more interesting. So let's also discuss that approach here. So this is the universal set consisting of all the people in the firm. So let us say set A is represented by one circle here, and set B I will represent with a different circle, right? So first we'll represent all the people that are present in A intersection B. So this is 10. Now the violet circle, set A should contain a total of 25 elements, out of which 10 are already in both A and B. So how many are only in A? It is 15. Similarly, how many people are employed only in B? It is 40. Right? A Venn diagram is a much more uh, useful to visualize the situation, right? So that was question 63. Question 64. A function is given, a function is of the form quadratic by quadratic, the range of the function. So it's a very familiar problem to most of us. We've come across this many times in class 11. So how do I find the range of the function? Let y equal x square minus x plus 4 by x square plus x plus 4. Now if I cross multiply, I get x square y plus xy plus 4y equals x square minus x plus 4. And if you rearrange the terms, you have y minus 1 times x square plus y plus 1 times x plus 4y minus 4 equal to 0. Right? Now, this is in the form of a quadratic equation. It is of the form ax square plus bx plus c equals 0. It is similar to a quadratic equation. So if you solve this quadratic equation, you must get a real value for x. And when will a quadratic equation have real values for x? When delta is greater than or equal to 0. That means y plus 1 whole square minus 4 times y minus 1 into c here is 4y minus 4. I can write that as 4 times y minus 1 again, greater than or equal to 0. So you have y plus 1 whole square minus 16 times y minus 1 whole square greater than or equal to 0. Now you can either expand this and solve, or you can rewrite this as y plus 1 plus 4 times y minus 1 into y plus 1 minus 4 times y minus 1 greater than or equal to 0. Right? So this expression here is of the form a square minus b square. A square minus b square. So I've written in the form a plus b into a minus b. Anyway, now you have 5y minus 3 into minus 3. No, I'm sorry, not minus 3. 5 minus 3y. Greater than or equal to 0. This means 5y minus 3 into 3y minus 5 less than or equal to 0. So the solution for this will be y belongs to closed interval 3 by 5 to 5 by 3. Right? Because this is an inequality of the form y minus alpha into y minus beta less than or equal to 0. So the solution should be y belongs to closed interval alpha to beta. Right? So yes, we have 3 by 5 to 5 by 3. Question 65. Let R be a relation from the set to itself such that R equals A comma B, where B is PQ, P comma Q are prime numbers. Okay, so now you need to find the number of ordered pairs in R, right? So what is the condition for A comma B to be an ordered pair in the relation? It means that A should be from the set, from the given set itself. So let us call this set A. Right? Let us say this set is a set capital A. Right? Also B belongs to A, but the given condition is B should be written as PQ. Right? B should be of the form PQ, where both P and Q are greater than or equal to 3. So how many prime numbers are greater than or equal to 3? First, we start with that primes greater than 3. So you have 5. Oh, in fact, you can equate 3 also. Primes greater than or equal to 3. So you have 3, 5, 7, 11, and so on. But I'm going to stop there. I am going to stop there because see, P into Q must belong to A, right? So I have 3, 5, 7, 11. These are all primes greater than or equal to 3. Now, how many products can I form here? So B can be either 3 square, 3 into 5, 5 into 7, 5 into 11, or let's put it in a more ordered fashion. So 3 square is a product of 2 primes. 3 into 5 is a product of 2 primes. 3 into 7 is a product of 2 primes. 3 into 11. So if I keep doing that, what is the maximum possible product I will get by multiplying 2 primes? So remember that product must be less than 60 because the product must belong to that set. So I think we'll stop at 11 because 11 square is 121, right? So if I keep writing this down, the next set of products is 5 square. Then I have 5 into 7, 5 into 11, right? Then the next product is 7 square, and that's it, right? So I can say A can be chosen in 60 ways because small a can be any number from 1 to 60, but B can be chosen in how many ways? So you have 3 square, 3 into 5, 3 into 7, 3 into 11. Okay. Okay, you can also write it as 3 into 13, 3 into 17, 3 into 19. So we have to make a table for this. So B is of the form P into Q. So if P is 3, then Q can be 3, 5, 7. Q can be 3, 5, 7, 11, 13, 17, 19. Remember, the product should be less than or equal to 60. And if P is 5, then Q can be 5, 7, 11. And if Q is 7, sorry, if P is 7, then Q can only be 7, right? I'm not taking P equals 11, Q equals 3 as a separate case because that part is ambiguous here, but it's about writing B as a product of 2 primes, right? So how many ways can you choose B? B can be written as 3 into 3, 3 into 5, 3 into 7, 3 into 11. So if I count all those cases, I have 7 plus 3 plus 1, 11, right? So A can be chosen in 60 ways, B can be chosen in 11 ways. So A comma B can be chosen in 660 ways, right? So that is this particular question. I think there's an element of permutations and combinations also to this. So that was question number 65. Question 66, greatest integer function. Okay, so 2 times step of 2x minus 5 will be 8. Now it's step of 2x minus 5 is 4, right? So step of 2x minus 5 equals 4, which means 2x minus 5 itself lies between 4 and 5, including 4 but not including 5. I just have to solve this inequality. I will get 9 less than or equal to 2x less than 10, which means 9 by 2 less than or equal to x less than 5. So x belongs to closed interval 9 by 2, open interval 5. Question 67, f of x is 1 by 7 minus sine 5x. Okay, so let y equal 1 by 7 minus 5 sine x. From here, I can say 7 minus 5 sine x equals 1 by y, which means sine 5x equals 7 minus 1 by y, right? Now, what is the condition for, what is the range of sine 5x? For all x belongs to R, sine 5x will lie between -1 to 1, which means 7 minus 1 by y lies between -1 to 1. So if I subtract 7 on all sides, I get -8 less than or equal to -1 by y less than or equal to -6. Now, if I multiply -1 on all sides, the inequality will change. So 6 less than or equal to 1 by y less than or equal to 8, right? I'm multiplying -1 across the inequality. So the sign, the direction of the inequality will change. Now, all sides of this inequality are positive, which means you can take reciprocal across this inequality. And then again, the inequality will change. So 1 by 6 greater than or equal to y greater than or equal to 1 by 8, which means y belongs to closed interval 1 by 8 to 1 by 6. Right? Question 68. 2 pi minus sine inverse 4 by 5 plus sine inverse 5 by 13 plus sine inverse 16 by 50. So one piece of advice here. There are a lot of formulae in inverse trigonometric functions. So whenever possible, try to convert everything to tan inverse, right? So I have sine inverse 4 by 5 plus sine inverse 5 by 13 plus sine inverse 16 by 65. This can be written as tan inverse 4 by 3 plus tan inverse 5 by 12 plus tan inverse, so 16 by, so what will this be? Okay, let's calculate that. So 65 square minus 16 square is 81 into 49. Yeah, so this will be tan inverse of 16 by 7, 9 into 7, 63. Right? You can convert sine inverse 16 by 5 into tan inverse, you get tan inverse 16 by 63. So now first we will evaluate two of the terms, right? Tan inverse 4 by 3 plus tan inverse 5 by 12. So how do we do this? Here you have an expression of the form tan inverse x plus tan inverse y, right? I know that x greater than 0, x is positive, y is positive, and xy is less than 1. So I can write this as tan inverse of x plus y by 1 minus xy. But remember the condition here, this is only applicable if both x and y are positive and xy is less than 1, right? In fact, if both x and y are positive and xy is greater than 1, then this result will change slightly. It will be pi plus tan inverse x plus y by 1 minus x2. So that is what I'm going to apply here. So I have x into y. The value of x into y is 5 by 9, which is less than 1. So the sum of the first two terms will be tan inverse 4 by 3 plus 5 by 12 by 1 minus 4 by 3 times 5 by 12. And then you also have tan inverse 16 by 63. Now, if I simplify this, I get tan inverse of 63 by 16 plus tan inverse 16 by 63. Right. So you have, after simplifying the first two terms, you have tan inverse 63 by 16. The third term is tan inverse 16 by 63. So the sum should be pi by 2, right? So the term inside the brackets here, the term inside this brackets, when we simplified, turned out to be pi by 2. So 2 pi minus pi by 2 is 3 pi by 2. Question 69. A, B, C are angles of a triangle with tan of A by 2, tan of B by 2, then the value of tan of C by 2 is. Okay, so what do we have in a triangle? We have A plus B plus C equals pi, which means A plus B by 2 equals pi minus C by 2. That is pi by 2 minus C by 2, right? So if you apply tan on both sides, then you will get tan of pi by 2 minus C by 2 equals tan of A by 2 plus B by 2. But what is tan of pi by 2 minus C by 2? It is cot C by 2. On the right hand side is tan of A by 2 plus B by 2. This I can write as tan of A by 2 plus tan of B by 2 by 1 minus tan of A by 2 into tan of B by 2. So numerator is 1. Denominator is 1 minus 2 by 9. That is 7 by 9. So cot C by 2 is 9 by 7. So tan C by 2 will be 7 by 9. So one very useful result in a triangle, right? Also in general, if A plus B plus C equals pi, right? Then I can say tan A plus tan B plus tan C equals tan A into tan B into tan C. It's a very useful result, not directly related to this problem, but you can make use of this whenever ABC are angles of a triangle. And yes, obviously, when we are writing this result, it is understood that tan A, tan B, tan C are all defined. None of them is a right angle, right? Question 70, the smallest positive value of x in degrees, satisfying the equation tan of x plus 100 degrees equals, okay, tan of x plus 50, tan of x, tan of x minus 50. So this would be okay. So let's look at one possibility here. Is there an alternative to checking the options? Because you have tan of x plus 100. Oh, okay. So x plus 15 plus x minus 15. All right, we'll come back to this question in a moment because I'm trying to look for something that does not involve uh, checking with the options. Question 71, 1 plus tan 5 degrees into 1 plus tan 10 degrees into 1 plus tan 15 degrees. Okay, so what you observe here is that the first term is 1 plus tan 5 degrees. The last term is 1 plus tan 45 degrees. In fact, if I write the last but one term, then it puts a lot into perspective. 1 plus tan 5 degrees into 1 plus tan 10 degrees and so on up to 1 plus tan 35 degrees into 1 plus tan 40 degrees, right? That's the last but one term. And then you have 1 plus tan 45 degrees. Now, among these terms, I know the value of the last term. The last term value is 2, right? So what do you observe when you compare the other terms here? For example, if I look at 1 plus tan 5 degrees into 1 plus tan 40 degrees, this is of the form a plus b equals pi by 4. That sum is pi by 4. Similarly, if I look at the angle in this term and the angle in this term, then their sum is 45 degrees. So one important result that we have is if a plus b is pi by 4, then 1 plus tan a into 1 plus tan b equals to, right? So based on that, you can write 1 plus tan 5 degree into 1 plus tan 40 degrees is 2. Similarly, 1 plus tan 10 degrees into 1 plus tan 35 degrees is also 2. So if you keep writing this way, at one point, you will come across 1 plus tan 20 degrees into 1 plus tan 25 degrees is 2. Right? So how many of these terms do we have here? We have 4 terms because we start with 5 degrees, then 10 degrees, then 15 degrees, then 20 degrees. Along with this, we've also calculated the last term, which is 1 plus tan 45 degrees is 2. So what is the product? You will get 2 power 5. Right? So the correct answer is k equals 5. Question 72. N of A is 2. N of P of A cross B is 64. Right? So the power set of A cross B. Right? How do you find the number of elements in the power set? To find the number of elements in the power set, to find number of elements in P of A, you need 2 power the number of elements in P. Right? So that by that logic, the number of elements in the power set of A cross B is 2 power the number of elements in A cross B. But this is given to be 64, which means the number of elements in A cross B is 6. Right? But how do you find the number of elements in A cross B? It is always number of elements in A into number of elements in B. So based on this, we can conclude that N of B is 3. Right? Question 73 is a similar one from set theory. Number of elements in A is 3. Right? So N of A is 3. And number of elements in the power set of B is 24 more than the number of elements in power set of A. So yes, first we can find number of elements in the power set of A, which is 2 cube, that is 8. Now it is given that number of elements in the power set of B is 24 more than number of elements in power set of A. So this is 32. But this means 2 power number of elements in B is 32. So that means number of elements in B is 5. Right? Question 74 is again similar to the one we solved earlier. Whenever possible, convert everything in terms of tan inverse. So you have theta is tan inverse 1 by 7 plus tan inverse 1 by 8 plus tan inverse 1 by 8. Right? So here you can use that method we used earlier. Simplify any 2 terms first and then use that result to combine that with the third term. Right? So here you can use tan inverse x plus tan inverse y. Question 75. Number of elements in the universal set is 20. Okay. So here you are being asked number of elements in A intersection, A union B whole complement. So this is number of elements in the universal set minus number of elements in A union B. But how do you find number of elements in A union B? From the addition theorem, you have number of elements in A union B is N of A plus n of b minus n of a intersection b, right? So you have all that information here. You can substitute it and you will get the answer. Okay, so let's go back to that particular problem. Smallest positive value of x in degrees satisfying the equation. X plus 100 tan of x plus 50. So tan of x plus 100. Okay. So there's one thing I can observe here. I can define let x plus 50 degrees as A and 50 degrees as B, right? Because I have a term on the right hand side. So then this equation will become tan of A plus B equals tan of A into, no, that is also not useful. Else can be done here. Okay. Right. Okay. So I have tan of x plus 100 degrees. This I can write as tan of x plus 50 minus of x minus 50, right? So the angles on the right hand side, I'm trying to relate the angles on the right hand side to those on the left hand side, right? So if that means the left hand side is tan of the form tan of A plus B minus C, and the right hand side is of the form tan A into tan B into tan C. All right, looks like we have to simply expand the term on the right hand side. Yeah, looks like we have to expand the term on the right hand side. So what is the right hand side? You have tan x into tan of x plus 50 degrees into tan of x minus 50 degrees. So if I write this down, I get tan x times tan square x minus tan square 50 degrees by 1 minus tan square x into tan square 50 degrees. Because if I expand tan of x plus 50 and tan of x minus 50 and multiply them, I will get an expression of this sort, right? Now, because this is equal to tan x plus tan 100 degrees by 1 minus tan x into tan 100 degrees. And this is this point I would verify the options, but I'm looking for an alternative to verifying the options, right? So the same question was asked in numerical type, then we would have a problem. So that's the only thing here. Right? If I take tan x equals A and tan 50 degrees equals B, then this means A into A square minus B square by 1 minus A square B square equals A plus 2B by 1 minus B square by 1 minus A times 2B by 1 minus B square. So you have A cube minus AB square by 1 minus A square B square equals A minus AB square plus 2B by 1 minus B square minus 2AB. Okay, so this is also not, it's getting lengthy in this case. Let's try something. Let's try an alternative here. So how are the angles related? I can observe one thing here, that if I subtract these two angles, I get 100 degrees. And if I subtract these two angles, again, I get 100 degrees, right? So let's try something with that. I can say tan of x plus 100 by tan x equals tan of x plus 50 degrees into tan of x minus 50 degrees, right? So I've isolated the angles to one side. So on one side, the difference of the angles is 100 degrees. On the other side, the difference of the angles is also 100 degrees. Now, if I convert this in terms of sine and cos, I have sine of x plus 100 by cos of x plus 100 into cos x by sin x equals sine of x plus 50 into sine of x minus 50 by cos of x plus 50 into cos of x minus 50, right? So left hand side will keep as it is, because on the right hand side, you can observe that the expression is of the form 2 sin A sin B by 2 cos A cos B. So sin square A minus sin square B by cos square A minus sin square B. Okay, so the right hand side can be written as sin square A minus sin square B by cos square A minus sin square B, right? And the left hand side is sin of x plus 100 cos x by cos of x plus 100 degrees into sin x, right? Now what I have here is an expression of the form A by B equals C by D. So I can make use of componendo and dividendo, which means A plus B by A minus B equals C plus D by C minus D, right? So if I make use of that, sin x plus 100 cos x plus cos of x plus 100 sin x whole divided by sin of x plus 100 cos x minus cos of x plus 100 sin x equals. Now in the numerator, if I do c plus d, I will get 1 minus 2 sine square 50 degrees. In the denominator, I will get sine square x minus cos square x, right? Sine square x minus cos square x. So on the left hand side, sine of x plus 100 cos x. What happens to the numerator? Numerator is in the form sine a cos b plus cos a sine b. So that is sine of 2x plus 100 degrees divided by, in the denominator it is sine of 100 degrees. On the right hand side, you have 1 minus 2 sine square 50 degrees, which can be written as cos 100 degrees, because 1 minus 2 sine square theta is cos theta, right? And the denominator is sine square x minus cos square x, which is minus cos 2x. Okay, so now you can cross multiply. If you cross multiply, you get minus sine of 2x plus 100 degrees into cos 2x equals sine 100 degrees into cos 100 degrees, right? Now you can multiply 2 on both sides. So minus 2 sine 2x plus 100 degrees into cos 2x equals 2 sine 100 degrees cos 100 degrees, right? The left hand side is of the form minus 2 sine A cos B, right? This is of the form 2 sine A cos B and can be written as sine of A plus B plus sine of A minus B. The right hand side is of the form 2 sine A cos A and can be written as sine 2A, right? So what can I write as the left hand side? Minus of 2 sine, minus of 2 sine A cos B is sine of A plus B, that is 4x plus 100 degrees, plus sine of A minus B, that is 100 degrees. Whereas the right hand side is 2 sine 100 cos 100. So that is sine 200 degrees. Okay, so now you have sine of 4x plus 100 degrees equals minus of sine 100 degrees plus sine 200 degrees. Mhm. Square minus sine square b cos square minus cos square b. All right, so I've been able to simplify up to this part here. Can we do something further with this? Rearrange the terms and bring sine 200 here. Okay, so this right hand side, sine 100 degrees, I can write as sine 80 degrees plus sine 200 degrees, I can write as minus sine 20 degrees, right? Because 100 is 180 minus 80 and 200 is 180 plus 20. So if I simplify this, I will get minus 2 sine, okay, sorry, 2 sine 50 degrees. No, it is 2 cos 50 degrees, 2 cos A plus B by 2, sine of A minus B by 2. All right, so you finally get sine of 4x plus 100 degrees equals minus cos 50 degrees, right? And minus cos 50 degrees can easily be written as sine of 140 degrees. 90 plus 50, sine 90 plus 50, no, minus cos 50. I have to change to sine. So I can write this as minus sine 40 degrees, that is sine of minus 40 degrees. Now you can, now I think substituting the options is easier, although you can also go for the general solution. If you are familiar with it, you can say 4x plus 100 is n pi plus minus 1 power n times minus 40 degrees. And then you can take different values of n and substitute, right? So if I take n equals 0, I get 4x plus 100 degrees equals minus 40 degrees, but this will not give me a positive value of x. But if I take n equals 1, I get 4x plus 100 degrees equals pi minus, no, not pi minus, pi plus 40 degrees, that is 220 degrees. Here pi radians is 180 degrees. So 4x equals 120 degrees. That means x equals 30 degrees. All right. So that was one slightly tricky question here, a very lengthy one, because we had to use different approaches here um, before closing in on an answer. So the correct answer here happens to be x equals 30 degrees, although it did take us a lot of thinking to rearrange the terms, right? So that is what uh, trigonometric equations is mostly about. You have to rearrange the terms here and there before you get some concrete solution. So remember earlier I tried to expand tan of x plus 50, tan of x minus 50 degrees, but I stopped in between. I paused in between to think about the next step, right? The next step wasn't going to be an easy one, right? Because you had a square and b square, you would get a third degree equation in terms of tan x, which is why I paused there and try to think about how else to solve this. So one approach seems to be this particular one where you group x plus 100 degrees and x together, and also x plus 50 degrees and x minus 50 degrees together, right? If I come across a better solution to this, I will definitely let you know in the follow-up video, right? But I hope you understood the discussion for this question. It is sort of lengthy and convoluted. It's not a very easy thing to process, but well, it's a very good question there. It really tested our patience, did it? Anyway, so that concludes our discussion. Thank you very much.